In the beginning, there was nothing we would recognize. No stars, no planets, no time as we know it. Then, in an instant, everything that is, was, and ever will be came into existence. It was a point of infinite heat and density. It was the birth of the cosmos. This was a moment of pure, brilliant light. From this singular event, the universe began its great unfolding. Every particle, every force, every law of nature emerged from this primordial fire. It was the start of an epic story, a story that is still being written across the fabric of space. This young universe was a tempestuous place. It was a chaotic soup of fundamental particles and radiation. But slowly, almost imperceptibly, order began to emerge from the chaos. Gravity, the quietest of forces, began its work. It pulled together wisps of hydrogen and helium gas. Over millions of years they collapsed, and deep within their cores, a new fire was ignited. The first stars were born, piercing the darkness that had reigned for so long. They were cosmic beacons in an otherwise empty void. These first stars were giants. They lived fast and died young. Their explosive deaths, called supernovae, scattered heavy elements across space. These were the building blocks of everything to come. Carbon, oxygen, iron. The very atoms that make up our world and our bodies were forged in these stellar furnaces. From this stardust, new generations of stars formed, and around them, planets began to coalesce. Galaxies, vast islands of stars, began to take shape, spinning through the expanding darkness. Our own Milky Way is just one of hundreds of billions of such galaxies. We look out into the night sky today, on this day, 2025, November 3rd, and we see the echoes of this ancient creation. The light from a distant star is a message from the past. It has traveled for thousands of years, millions of years, even billions of years to reach our eyes. It tells a story of cosmic birth and stellar evolution. It is a reminder that the universe is not static. It is a dynamic, evolving entity. It had a beginning. And this simple fact leads us to a profound and difficult question. If the universe had a beginning, must it also have an end? Well, that's the question that lingers. For a long time, we believed gravity was the master of the cosmos. We thought the universe's expansion, started by the Big Bang, might be slowing down. Gravity pulls everything together. It seemed logical that this attraction would act as a brake on the universe. Perhaps the expansion would slow to a halt, or perhaps it would even reverse, pulling everything back together. But the universe holds surprises. When we looked deeper, we found something else at work, something unexpected. Something that is pushing everything apart with ever-increasing speed. This mysterious influence is called dark energy. We cannot see it. We cannot touch it. We do not yet know what it is, but we can see its effects everywhere we look. It acts like a kind of anti-gravity. It is woven into the fabric of space itself, and it is causing the universe to accelerate its expansion. Galaxies are not just moving away from each other. They are flying away at a faster and faster rate. This discovery changed everything we thought we knew about the final destiny of the cosmos. The fate of everything now seems to depend on the nature of this strange, invisible force. Imagine the universe as a great cosmic ocean. The galaxies are like ships sailing on its surface. For billions of years, these ships have been drifting apart. Now, we realize the ocean itself is swelling. The space between the ships is stretching, carrying them away from each other at an accelerating pace. Eventually, the light from the most distant galaxies will be stretched so much that it will no longer be visible to us. They will disappear over a cosmic horizon, lost to us forever. The night sky of the far future will be a much emptier, much darker place than the one we know today. This acceleration is the dominant force shaping the universe's future. It is a quiet but relentless process. It works on the largest scales imaginable, determining the ultimate arrangement of matter and energy. As space expands, the density of matter and radiation within it decreases, but the density of dark energy appears to remain constant. This means that as time goes on, its influence only grows stronger. It is a silent cosmic engine, pushing the universe toward a future that we are only just beginning to comprehend. The fate of everything hangs in the balance of this cosmic tug-of-war. Science offers us several possible futures, each one determined by the cosmic battle between gravity and dark energy. The first, and perhaps most likely scenario, is a slow, cold end. It is called the heat death of the universe. In this future, the expansion continues forever. Stars will continue to burn for trillions of years. But one by one, they will exhaust their fuel. They will cool down and fade into darkness. Black dwarfs, neutron stars. No new stars will form. Galaxies grow dark and cold, populated only by dead husks. A second possibility is far more violent. If dark energy is even more powerful than we think, it could lead to the Big Rip. The accelerating expansion becomes unstoppable. It overcomes all other forces. First, it tears apart clusters of galaxies. Then it rips apart galaxies themselves. Stars are unbound from their orbits. Solar systems become unbound. Planets are flung into the cold void. The end is swift and total. Then there is a third path, a return to the beginning. This is the Big Crunch. It would happen if dark energy weakens. Gravity becomes dominant again. Expansion slows, stops, and reverses. Everything falls back together. Galaxies rush toward one another, colliding in a cataclysmic blaze. The universe grows hotter and denser. All space and time collapses into a single, infinitely hot point, maybe birthing a new universe. Each scenario paints a different picture of the end. Heat death, silence and stillness, a slow fade into eternal night. Big Rip, sudden catastrophic violence, a tear in reality. Big Crunch, fire and compression, a collapse mirroring the universe's birth. Which path the universe will take is one of the greatest unanswered questions in science. The answer lies hidden in the precise nature of the dark energy between the stars. It is important to understand the timescales we are talking about. These are not human timescales. They are not even geological timescales. They are cosmic timescales, so vast they defy our everyday intuition. The end of the universe is not coming next week, or next year, or even in a million years. If the heat death is our fate, the last star will not burn out for another 100 trillion years. This is a number so large that it is almost meaningless to us. It is thousands of times longer than the current age of the universe. After the last star dies, the universe will enter what is called the degenerate era. The cosmos will be a dark and quiet place, populated by the remnants of stars. Black holes, neutron stars, cold, dead white dwarfs. But even then, the story is not over. Over even longer timescales, galactic structures will dissolve as their stellar corpses are ejected into intergalactic space. The universe will become a thin, uniform soup of scattered objects. And even these objects are not permanent. Quantum mechanics predicts that even matter itself may not be stable over infinite time. Black holes will become the dominant objects in this far-flung future. They will slowly sweep up stray matter, growing larger and larger. Yet they are not eternal. Stephen Hawking showed that black holes themselves slowly evaporate. They emit a faint glow of particles now known as Hawking radiation. For a stellar mass black hole, this process takes an unimaginably long time, far longer than the 100 trillion years of the stelliferous era. For the supermassive black holes at the center of galaxies, it could take a Google years. That is a 1 followed by 100 zeros. After the last black hole has evaporated, the universe will enter its final stage. The black hole era will give way to the dark era. The cosmos will be an almost perfect vacuum, filled with only a sparse mist of photons, neutrinos, other fundamental particles. All organized matter will have decayed. All free energy will have been spent. The universe will be a cold, dark, and empty place, approaching a state of maximum entropy. This is the ultimate silence, a final state of equilibrium from which no work can ever be extracted again. The story will have finally come to a complete and total end. We stand on a small planet orbiting a single average star. Our star is one of hundreds of billions in a galaxy that is itself just one of countless others. Our lives are a fleeting moment in the 14 billion year history of the cosmos. From this tiny vantage point, we look out into the vastness and we ask these questions, how did it all begin and how will it all end? The fact that we can even pose these questions is perhaps the most remarkable thing of all. We are a part of the universe that has become self-aware. Our science is a testament to human curiosity. We build vast telescopes to capture ancient light. We design complex experiments to probe the nature of matter and energy. We use mathematics to model the birth and death of stars, galaxies, and the universe itself. We are detectives, piecing together clues from the distant past to predict the far future. The cosmic story is not just something we observe. It is a mystery we are actively trying to solve. And with each new discovery, the story becomes richer, deeper, and more profound. The final fate of everything is a story of immense grandeur and terror. It speaks of scales of time and space that dwarf our comprehension. It can make us feel infinitesimally small and insignificant. And yet, there is also a strange beauty in it. There is a solemn peace in the slow fade of heat death. There is a terrible majesty in the fiery collapse of a big crunch. These stories are not just about physics and cosmology. They are about our own relationship with the universe. They define the ultimate context for our existence. For now, the stars continue to shine. Galaxies continue their slow, graceful dance. And here on Earth, we continue to watch, to wonder, and to learn. The light that reaches us tonight from the depths of space carries with it the memory of creation and the seeds of the future. The final answer is still out there, waiting in the cold, silent darkness between the stars. It reminds us how precious this moment is, this brief, warm, sunlit instant in the life of the cosmos. Knowing that it will all end, does that not make the now infinitely more beautiful?